We are in section 7.2 on page 5 of our notes. 7.2 is estimating a population mean. So remember, x bar is the point estimate of mu. We can use a z statistic to determine the probability of getting a certain sample mean. If the sample is sufficiently large, we say greater than 30. If the sample is small, then the distribution is not normally distributed, and a t statistic must be used instead. So a new distribution. The t distribution has more spread than the z distribution. In the picture down below, you guys can see that as t gets bigger, it gets a little bit more normal, but you can see when we have a population that's smaller than 30 versus when we have one that is greater than 30. The t distribution is typically used to study the mean of a population rather than in a study of individuals within a population. In particular, it's used in many cases when you use the data to estimate the population mean. For example, using the sample mean of 20 homes to estimate the average price of all new homes in California, or when you use data to test someone's claim that the population mean, for example, is it true that the mean price of all new homes in California is $500,000? The connection between the normal distribution and the t distribution is that the t distribution is often used for analyzing the mean of a population if the population has a normal distribution or fairly close to it. Its role is especially important. So its role is especially important if your data set is small, or the big one here is if you don't know the standard deviation of the population, which is often the case. So we have the student t distribution. It's a formula that you do not need to know because we are using the calculator. And then it talks about with n minus 1 degrees of freedom. We don't really get into the meaning of what the degrees of freedom are, but n minus 1, this is going to be your sample minus 1. So just quickly, there's some properties right below that talk about the t distribution. It says properties of the t distribution. T distribution is different for different degrees of freedom depending on your size of your sample. It is symmetric to 0, and it's centered at 0, so it's like the z, our standard normal. The area under the curve is 1, and it's split, so half on the left and half on the right from the mean. As t increases or decreases without bounds, it approaches 0 but never equals it. The area in the tails is a little bit greater than the area in the standard normal curve. And the sample size n increases, the density curve gets closer to the standard normal curve. This is called the law of large numbers. So at the top of the next page, it says remember that z sub alpha is used to represent the z-scores whose area under the normal curve and to the right of z is alpha. So we have now the same thing. It's going to be t of alpha is used to represent the t value whose area under the t distribution and to the right of t is alpha. So we have a couple calculator steps here. The first one that we have, we'll give a star to, says to find the t value with a TI-84 graphing calculator. We're going to go ahead and go to second vars, which is distributions. And number 4 is inverse t. And this is what we use for our t distribution. If we know sigma, which again isn't very often, then we use number 3, which is inverse norm. And we use that z distribution. So inputting this in on your calculator for inverse t, we're going to have the area to the left and the degrees of freedom, which again was n minus 1. And inverse norm is back from chapter 6. And so we went through that before, and if you don't remember how to use your calculator,